Assalamualaikum. We are from Group 13. We're presenting about analysis of YOLO model for non-your customer KYC application.
Hi, Assalamualaikum. My name is Ifan. I will now present a methodology for our KYC facial authentication system. As you can see in the block diagram on the screen, we did not just train a model, we built a complete engineering pipeline, breaking it into three phases ensure our experiment is controlled. The data is prepared cleanly before the model ever see it. Phase 1 is a dataset engineering. This is where we collect raw images, resize them, draw bounding boxes, and apply data augmentation to grow our dataset. Phase 2 is a network training. We split our dataset into three parts: load pre-trained weeks to speed up learning, and train the YOLO models to recognize the faces. Finally, phase 3 is an inference evaluation. This is where we test the trained model using a real-time webcam feed. We filter out bad detection and measure performance using metrics like MAP and FPS. Moving on to our dataset shown in this slide, our target classes have 7% to make sure our model is balanced and does not become biased toward 1%. We collected the exact same number of images for everyone. We included pictures of us holding our metric cards as well as normal background photos. After applying data augmentation, we had a total of 411 images. We carefully split this data into three sets: 69% for training to teach the model, 90% for validation to check accuracy during training, and 12% for testing to evaluate the final result. For a model to learn properly, the data must be labeled accurately. This slide shows our annotation process using RoboFlow. We manually threw tight bounding boxes around the face in every single image. We made sure to crop out as much background as possible, focusing only on the face, as you can see in this example for the class NS. This process converts the image into YOLO format, which is a simple text file containing the class ID and the X and Y coordinates of the face. Because collecting thousands of photos manually is difficult, we use a data augmentation to multiply our dataset and simulate the real-world problems. For every original image, we generate three augmented versions. First, we apply rotation up to 15 degrees to simulate user holding their phone or ID card at an angle. Second, we change the brightness by plus minus 20% to mimic harsh sunlight or dark rooms. Finally, we added a small amount of blur and digital noise. This is a very important step because it trains the model to work perfectly even if the user has a cheap, low quality webcam. The core of our project is an engineering experiment comparing two different models, YOLO V11 Nano and YOLO V11 Small. We choose YOLO V11 Nano because it is incredibly lightweight and fast. It requires very little processing power, making it perfect for choice for edge computing. On the other hand, we choose a YOLO version 11 Small because it is a deeper network with more parameters. It is slightly slower, but it has higher accuracy. This makes it better suited for server-side deployment. Finally, to make this a fair comparison, we train both models using the exact same hardware and parameter. We train the models on the Google Colab using an NVIDIA T4 GPU for 100 watts. For the image size, we make it a 512 pixels. This decision speed up our training time and gave us a much higher FPS during live webcam testing. Lastly, in our final Python script, we set the confidence threshold to zero point 0.6. So this means the system will ignore any face it is not highly confident about, keeping the KYC process secure.
My name is Mazina Zebinti Mazu. We met today. We see 23008 and I'll continue for the result analysis. And this is YOLO V11S. As you can see, this is the graph, the F1 confidence curve, precision confidence curve, precision recall curve, and the recall confidence curve. And all overall, the model show strong and consistent detection and across all seven classes near a zero point 0.5 confidence threshold. Okay, next is YOLO V11X. It's same with the previous, which is overall the model for the YOLO V11N model produced a good and stable detection performance over all 7 classes and slightly poor performance in muslin class despite the relatively small validation set of 77 images out of 285 training image. Okay, for the confusion matrix, YOLO V11N shows consistency per class accuracy, which Anas, Ani, Hakim, and Kasim are reaching the perfect TPR and only minor dips in Ifan and Zwani, while YOLO V11S shows more pronounced weakness in Ani, which is you can see 0.77, but Anas, Hakimi, and Zwani also reaching 1. And the both model show some background misclassification, but YOLO V11N its errors are more evenly spread, and while YOLO V11S are concentrated in one class. Okay, since both models are share the same image dataset, the instance count, the bounding box, and parallelogram are identical. And where the here, as you can see, Ani has the most instance, which is 54, and Anas and Irfan the fewest, which is 33. And the object centers of the box dimension follow the same patterns in both cases, where this confirms that any performance differences between the two models stem from architecture, not the data. Okay, for the fact, both models show similar training loss trends and decreasing smoothly over 100 approach. However, YOLO V11N shows more fluctuation in validation losses and precision recall curve, while YOLO V11S converges more smoothly and stably. Overall, YOLO V11S offers more stable and converges stronger performance under stricter IOU threshold.
So hello everyone, my name is Muhammad Anik Wazir bin Danilo and my matrix number is DE230037. So today our group will demonstrate our real-time KYC facial authentication system developed for our intelligent control system assignment. So we show you how we prepare our data set, configure our training environment, and compare two state-of-the-art model YOLO V11 Nano and YOLO V11 Small. So as you can see here, we configure our development environment directly in a Google Colab. In the first cell, we install the required Ultralitic framework along with a RoboFlow to manage our dataset. So we then import the YOLO class and use our unique API key to download version 2 of our custom KYC facial dataset from our RoboFlow workspace, ensuring it is a properly structured for the YOLO V11 model layout. So moving to the model training, we set up fair benchmarking environment by training two separate model size under identical hyperparameter. So for the first model, we initiate training on the YOLO V11 Nano architecture using a YOLO 11N.pt. So base weight. So for the second model, we train the YOLO V11 small version using YOLO 11S.pt. So both model configured to run for 100 epoch with an image size of 512 pixels. So we enable plotting to automatically generate our performance graph inside the project folder. So finally, we set up the pipeline here to evaluate the model using a predict mode command. We pass our video name Vude MP4 to both network using a defined confidence threshold of 0.6 and set the safe true to output our final label video. So as you can see in the active terminal log for the YOLO 11 small model, the execution runs smoothly on a Tesla T4 GPU. So the model compiles it 101 layer and actively process the video frame by frame. So successfully detecting and clearing target individual from our dataset such as Hakimi, Zuaini, Anis, Mazlin, Anik, Irfan, Kasim, and Anas in the real time. So later on, I will show how our webcam works. So as you can see on my screen right now, this our real-time KYC authentication system is actively running. So this system is successfully tracked my face with a blue bounding box and correctly identified as me, Anik, with a highest score confidence score of 0.6, 0.7, while maintaining a smooth processing speed of 21 FPS. So right now I'm holding my physical metal card here to verify the live system facial authentication match my official ID document perfectly, as you can see here. So let's move on to our group 1 minute test video to see how the system handle the rest of our team members. So now let's look at our 1 minute test video where we benchmark both models side by side under the real world operational condition. So on the left side of the screen we have the YOLO V11 small, and on the right side we have the YOLO V11 nano. So as the video run, an interesting detail to note is that the YOLO V11 nano model on the right often display a higher individual confidence score. So, however, when looking at the overall performance, YOLO Variable Small is clearly the better model because it detects more phase consistently across the entire video frame. While the Nano model get high score on insulated phase, the small model excel at multi-phase detection, capturing our group member more reliable as people move around. So we do observe a shared limitation in both versions regarding fine grain facial recognition. There are moments when the system undergoes identity mixing, slightly swapping them, such as misidentifying Zoani as a Hakimi in the YOLO V11 Nano. Even with the minor name swapping issue, YOLO V11 Small remain our definitive recommendation for this KYC application. So its ability to successfully detect and lock onto a higher number of faces simultaneously make it more robust and dependable choice for real-time intelligent control system. So I think that's all for our video demonstration. Thank you.